After light, previously we had been devising about some of the things about like the property of the light and the importance of the light and like how can we see that light has energy. So we have the evidences, we have the examples of the photosynthesis being carried out by the plant and the conversion of solar energy into electricity. Then we have learned about that light travels at a speed of about 3 lakh kilometer per second. And on the basis of light, on the sources of light, you have natural and artificial sources. Then talking about the moon also we have discussed, and we had learned like why light is necessary. It is necessary to provide us vision, right? It helps us in vision, we should be saying that. And plants carries the photosynthesis, right? They are at the top of the food chain, basically the very first organism of the food chain. They're the primary producers, right? It will supporting the food chain and helps produce oxygen too. Then the light also regulates the biological clock, right? Like when we are going to sleep and wake, so we get to see that light basically helps to regulate the biological rhythmic clock also in the living things, right? Like the sleep wake cycle of the humans. Then sunlight has energy in it, that is the primary source of energy for the earth's ecosystem. It also regulates the temperature and the weather patterns of the planet earth, and various technological applications are also based on light. Okay, answer the following question. Answer it in the class, not in the chat box. I won't be able to look at from the chat box.
B. It is required to. It is required for the process of photosynthesis.
Good. Next, what role does light play in the human body's biological clock?
A.
Hmm, very good. So it triggers the release of melatonin in bright conditions. Right now, melatonin is the hormone secreted by the pineal gland, pineal, pineal gland, that controls the rhythmic cycle of the body, sleep and wake cycle of the body, particularly. Next question.
B.
Very good. So it stimulates the rod and cone cells. Next,
B.
it provides energy that sustains the food chain. Next,
Also B.
good. Now, how do we see objects? As we know that we are able to see the objects as the reflected rays of light will be entering into our eyes, and the information is sent to the brain for the purpose of processing it, right? About the reflection, we have discussed that there are two types of reflection: regular reflection and diffuse reflection, right? So whenever light will be falling onto any surface, so it will get reflected, right? If that object is a very well polished and shiny surface like that of a mirror, so it will result in the image formation also, right? But if that surface is not smooth and shiny but has a very rough, it is very rough, so thereby it will not result in the image formation, right? So there are two types of reflection: regular and diffuse reflection. It occurs on the smooth surface, but it occurs on the rough surface. And this is how the rays of light will be reflected off from from a smooth and shiny object. But from a rough surface, it is dispersed into different directions, right? Now, it is diffusing into different directions like that. Then there are namely two different types of mirrors. One is the plane mirror, and the other type of mirror are spherical mirrors, which are further classified into the concave mirror and the convex mirror. The concave mirror, they are curved inward, right? The concave mirror, which is one of the spherical mirror, its reflecting surface is bent inward like this. And as the rays of light falls onto the concave mirror, thereby what happens? After deflection from this, it will come back to meet at a point. They will come back to meet at a point like this. So this is a concave mirror. And as the rays of light after of falling onto the concave mirror, after 1 minute, as the rays of light will be falling onto the concave mirror, so it will be converging at a common point called as the focal point. Getting it? No? So that is the concave mirror, and the concave mirror forms a magnified image. It forms a magnified image. So that was all about the concave mirror. Its reflecting surface is bent inward and gives a magnified view of an object. Okay. Next, you have the convex mirror. In the case of convex mirror, take a look at the diagram here. The reflecting surface, this is the reflecting surface here, this side. It is bent onward. And as the rays of light are falling on it, it diverges into different directions. Right? It diverges into different directions. It will appear as if these diverge or these reflected rays of light are emerging from this common point, but in reality they are reflecting off into different directions. Good. So concave mirror, can we also call this as the converging mirror?
Yes, sir.
So that is called as converging mirror also. And this one is the convex mirror, which we also call as the diverging mirror. What are its applications?
It's like the objects which appear in it are like smaller, and it gives a
Hmm.
wide, like the view
Wide
is
angle of view.
yes, wide angle of view.
Hmm. So image form in this is diminished, right? Image form is diminished, plus it is virtual, it is erect, and gives a wide angle view. Wide angle view, thereby it is used in rear view mirrors of the car. So there it is being used as rear view mirrors. Similarly, the concave mirror also has some applications, right? So its applications are such that, like it is used in the flashlight, it is used in the flashlights. Okay. Then it is also used by the dentist. It is also as used by the dentist, so dentist mirror, right? It is also used in the solar cookers. These are some of the examples. Okay. Now the image formed by this concave mirror, now image formed by this one can either be virtual, can either be real, right? Can either be erect, can either be inverted, can either be erect or can either be inverted. Getting it now? Can be smaller, can be of same size, and could be bigger in size also. Getting it now?
Yes, sir.
Good. So these were the properties of these two spherical mirrors. Okay. So this is basically the summary of the things which we have discussed so far. And it is particularly talking about the nature of the image and the reflecting surface. So for concave curve inward, for this it is outward, for this it can be real or virtual, and for the convex it is always virtual. Answer the question.
Mirror.
Correct. By the way, is has anyone else joined the class today, or is there only you?
Only me.
Okay. If you have questions from other than the light chapter, also you can ask.
Not really.
Okay. Okay. Maximum part of light is reflected by
Opaque.
opaque object. Good. Which type of mirror is used as a rear view mirror in vehicles?
Convex mirror.
Convex. Next.
Virtual and erect.
Good. And this one,
Concave.
concave mirror. You know, the concave mirror is opposite to concave lens, and similarly, convex mirror is opposite to the convex lens. Getting it, no? Like, that concave mirror, we call this as the converging mirror, no? call as converging mirror. But if I were to talk about the concave lens, so from the concave lens, what happens? Like this is the concave lens. Now, as the rays of light passes through this, it diverges. So, what should I call this concave lens? Concave lens,
Diverging.
diverging. Okay, now so many times the students get confused in this. Okay, now so the concave lens is diverging, but the concave mirror is converging. Same is the case with the convex mirror also. Convex mirror is diverging, but the convex lens is converging. Okay, continue.
Virtual, erect, and diminished.
Diminished. Very good. Next,
Concave mirror.
concave mirror. Good. Okay. Now, we have discussed about the laws of reflection also, right? Whenever light strikes a smooth and shiny surface, it bounces back, and that is what reflection is. The incoming ray of light is incident ray. The reflected light is the reflected ray simply, and the normal is the perpendicular imaginary line drawn to the mirror. Okay, it's an imaginary line that is drawn perpendicular to the reflecting surface, and it is drawn at the point where the incident ray strikes the surface. At this point, the angle between the normal and this incident ray is the angle of incidence, and this one is the angle of reflection formed between the normal line and reflected light. There are two laws of reflection. The first one, as we know, that angle I is equal to angle R, the angle of incidence, and the angle of reflection equal to one another. Second law says that all these rays of light, all these rays of light lies on the same plane. That is, incident ray, the reflected ray, the normal at the point of incidence, all lie in the same plane. So these are the two laws of reflection which we have discussed. Okay. Before we continue further, read the question. Okay, and answer this question. Light from here.
A light ray strikes a plane mirror at the angle of 35 degrees with the surface of the mirror. Find angle of incidence, angle of reflection, the angle between the incident ray and the reflected ray.
Okay, take your time and answer this question.
The first one is 35.
No, that is not 35. See, the angle is formed between the incident ray and the surface of the mirror. Like this is the incident. One minute, let me draw it from here. This is the plane mirror. Okay, and say that this is the incident ray falling on it. This is the normal line we will draw at the point of incidence. This is the angle I. This one is the reflected ray. Let me write it here. Reflected ray. That one is the incident ray. Now read the question once again and at least read this question twice. So it is saying that strikes a plane mirror at an angle of 35 degree with the surface of the mirror. The angle of 35 degree is with the surface of the mirror. This is the surface of the mirror now, and this is the incident ray. So shouldn't the angle 35 be here? You got it now? So that is angle
Yes.
30, 35. Okay. Continue now. Continue it. Solve it. If this is 35 degree, as you know that this complete angle is going to be 90 degree, right? This one is 35. So what will be angle I equal to?
85.
How much?
85.
How is it going to be 85? This complete angle is 90 degree. This thing, let me show you. See, this angle here
Oh,
is
wait,
equal to,
55. Like I did it by mistake.
okay, no issue. So that is 55 now, very good. So it's 55 degree. So angle I is equal to 55. What about angle R?
Also 55.
Okay. And the third question, angle between the incident ray and the reflected ray. Meaning that,
110.
exactly. So that is going to be 110 degree. Very good. Okay. So question could be framed in this manner also. Okay. This is very simple. The answer is
Incident ray. Oh, wait, no, normal ray.
normal. No. Good. Next.
2.
Next.
Equal
Okay. And
angle of incidence.
read the question once again.
Angle of reflection.
Angle of reflection. No. Good. Next.
Regular reflection.
That is regular reflection. Good. Here you can take a look at the regular reflection, and this one is the diffuse reflection. So which of the following is going to result in the diffuse reflection? That's obviously
Wood.
wood. Okay, answer the question. Which of the following statement is true about diffuse reflection?
C.
That is C. Very good. The incident angle is equal to the reflected angle for all the rays. This will be true for
For
this
like
is
normal
hmm,
reflection.
yeah, for regular reflection.
Regular.
Hmm. Next,
The angle and the reflecting surface must be opaque.
it must be opaque. Okay, it's regular reflection now. Regular reflection, like say for example, a piece of rock is also opaque, right? Rocky surface is also opaque in nature, and the plane mirror is also opaque in nature, right? But from will the regular reflection occur from both of them?
No, sir.
No. Go through other options also.
The surface must be the surface should be smooth and polished.
Very good.
C.
C. No. Irrespective of the type of reflection, laws of reflection is always followed. Keep this thing in mind that irrespective of the type of reflection, whether it is regular or whether it is irregular, laws of reflection are applicable everywhere. Getting it now?
And then B.
Then it is going to be B. Very good. Okay. Like in the case of regular reflection, what we have seen that, like these are the incident rays of light, right? Incident rays of light, and these are the reflected rays of light. Now, the angle of incidence and the angle of reflection for all the rays are equal to one another. Got it? Like if this is 1 degree, this is 1 degree. This is 1 degree, that is also 1 degree. This is 1 degree, that is also 1 degree. Getting it now?
Yes,
But
sir.
that is not the case in the irregular reflection. Suppose that this is the incident ray and the reflected ray. That is the another incident ray, and that is another reflected ray. So here the angle of incidence is 2 degree. Suppose this is also 2 degree. Okay, it is applicable. This one is suppose 4 degree. This is also 4 degree. That is applicable. First law of reflection is applicable. But are the incident angle and reflected angle equal for all the rays here?
No, sir.
No. Here it's two, here it's four. Good. Last, fourth question. That is D. Repeat again.
D, the light
D.
passing through a frosted glass.
Okay, good. No, 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 no. It's a frosted glass window, no? No. Frosted glass window, you understand or not? Like, you cannot look from look very clearly like what is the object is standing behind that, and it will give
Okay.
a blurry image. Then it is inner sunlight falling on a still water surface. Then we had also discussed about the formation of image by a plane mirror, right? So what happens basically, like we had this object AB standing in front of the plane mirror of height h. So these are the light that is coming from the object AB. Like this is the incident ray AB, incident ray AO, and then you have incident ray BO, right? And then we have one more incident ray. Let's call this as ray BN, right? All these are the incident rays, and all of them are going to get reflected back now. AB gets reflected back as BA. AO is reflected as OA. Sorry, AO is reflected as OC, right? And then you have BO is reflected as OB. BN is reflected as NE. So after reflection, what is happening? All the rays of light have been drawn backward, right? And they are merging at some point. So the point where all these rays of reflected rays of light are merging together, when drawn behind the mirror, it results in the formation of image. This is the point where the image is formed. And it is observed that the image form has the same height as that of the object. The distance between the image and the mirror and the object and the mirror is always equal. Like if this is suppose if this distance is 5 meter, so is the distance between the image also and the mirror. If this is 5 meter, so that is also 5 meter. So we did discuss that point also. And of course, the image form head is erect or basically upright, is laterally inverted and virtual also. It is a virtual image because it is formed by the apparent intersection of diverging rays. What does it mean, that? It means that the rays of light appears to be meeting at a point. Or are they actually meeting? Yes, Ibrahim?
No.
No, they appear to be meeting at a point. Okay, so hope you have got it so far. Read the given paragraph.
Lateral inversion refers to the reversal of left and right when an image is formed by a plane mirror. It is the phenomena where the image of an object appears to be flipped horizontally.
Okay, so as if you were to 100, yeah, if you're seeing that as a, if I am standing in front of the mirror with my right hand raised, so in the mirror it will appear as if I have risen my left hand. So that is because of the left right inversion of the image formed here. And it has some applications, as we see that the letter on the ambulance, the word ambulance is on purpose written inverted so that in the rear view mirror of the vehicles it will be read correctly, and thereby we can give way to the ambulance to go further. Answer the following question.
D.
Good. Answer this one.
Lateral inversion.
That is lateral inversion. Further, there are two types of image, one that is real image and one that is virtual image. Now, moments ago, we have discussed that in the case of the plane mirror, a virtual image is being formed. Why is it so? Because, first of all, this image that is formed, you cannot obtain it on a screen. right now. Like this image that is being formed here, can you obtain it on a projector screen, or can you obtain it on a surface of wall or anywhere? You
No,
cannot
sir.
know. No. And how this image is formed? Because because the rays of light appears to be meeting at a point, they are not actually meeting at a point. Are the reflected rays meeting at a point actually?
No, sir.
No. That's why they have been shown by the dotted lines. So the rays of light only appears to be meeting at a point, and you cannot obtain it on a screen, hence it's a virtual image. Then the real images are those kind of images, like for example, the rays of light coming from the projector falls onto the screen, and the rays of light are actually meeting here, and that's a real image which can be obtained on a screen, can be obtained on any surface, even if it's a wall, it can be obtained there. So that is one thing. Then we had discussed about the multiple reflection also, that if two or more than two plane mirrors were to be kept inclined at some angle, so due to multiple reflections, multiple images of that object will be formed, but it depends upon some laws which we have discussed. As you can see in this image also, like the coin has been placed at an angle and multiple images of the coin has formed here. And this multiple reflection concept has many applications. Particularly, it has application in the construction of devices like periscopes that is used in the submarines in order to look at objects that are not in direct line of sight. Right now, as you can see in the periscope, that the objects that are not in direct line of sight, I can look at this object even with the help of the periscope. I can look at this object. Even there's an obstacle behind between the object and the me, I can look at this. Okay, now direct line of sight means that if the object were to be standing just in front of me or within the reach of my eyes. Correct. And there are some toys also that works on the principle of multiple reflections. Before we continue, let's get back to this formula. So there are two formulas required to find how many images will be formed in the case of multiple reflection. One is n equals to 360 upon theta, another is 360 upon theta minus 1. So if the value of the n comes to be odd, this is the formula that is to be used. And if the value of the n comes to be even number, so this is the formula that we have to use here. That after getting the value, you have to subtract one from it. Hope you have understood this.
Yes, sir.
Okay. I'm going to change the value because this you have solved previously. So suppose if the angle here is 72 degree, so how many images will be formed? If it is 72, tell me. If it is 36, tell me. And if it is 18, tell me. Yes, Ibrahim, all you have to do is use the formula now. N equals to 360 upon theta. Theta here is the angle between the plane mirrors. Okay. All these are the values of different, these are the different angles. That is the theta. Yes, what's the answer for the 72 degree?
1 second, sir.
Okay, okay, take your time.
First one is 5.
It's 5 degree. Good.
Second one is 10.
No. 10 is the even number, no?
And 9.
9. And
19.
19. Good. Okay, now we have a word problem. Okay. Read the question carefully. Read the question at least twice and then only solve it. Okay. Continue. Have you got the exam date sheet?
No, sir.
Okay.
First one is 30.
First one is 30 degree. Okay. So two plane mirrors are inclined at 90 degree. Let's say that the light has a strike in one mirror at an angle of 30 degree with the normal.
Second one is also 30.
Okay, this one is 30 and that one is 30. Let me cross check it. So this one is 30 degree given in the question with the normal. At what angle will the ray reflect from the first mirror? Okay, that is going to be 30 degree. Good. After reflecting from the first mirror, the ray strikes the second mirror. At what angle will it reflect from the second mirror? You are saying it to be 30 degree. Okay, see. This one is 30 degree. Suppose if you were like we have, see, I'm going to draw the normal. This is the normal, and that's the reflected ray of light from the second mirror. Now here we have constructed a square. Okay, now this is a square. This is 30 degree, so that will be 60 degree, right? It's 60. This one is 90 degree. So thereby this angle should be how much? Yes. In a triangle, what is the sum of all three angles? In a
180.
triangle, 180. So 90 and 60, and this one is going to be 30 degree, right?
80. Yes.
Okay. So if this one is 30, what will be the value of this angle here? And you know already that normal is drawn perpendicular now. So this much of
Yes.
angle is 90. So what would be this angle? This angle
45.
I. How is it 45? Do the calculation properly. This is already mentioned as 30 degrees. See, this much here. 1 minute. This much of angle is 30. Okay. This much is 30 degree. You have to find this much of angle. This much. Both of them together, the green and the blue one, both of them together are equal to 90 degree. The blue one is 30. What will be the green one?
60.
60, no? So angle I is equal to 60, right? So angle R is also going to be same, isn't it? Angle R will also be same. So it is not 30 but 60 degree. Hope you have understood it. Did you got it or not? I think you are getting it. Further, we have also learned about the types of lens. So we have basically two types of lens, right? One is the concave and another one is the convex lens. A convex lens, also being called as a converging lens, is thicker at the middle while thinner at the edges. And as the rays of light will be passing through it, it will converge to meet at a point. In the case of concave lens, when the rays of light will pass through the concave lens, so it will diverge into different directions and hence is also called as diverging lens. Both of them are having their own uses. Okay. In the case of the concave lens, we see that the images that are formed are usually smaller than that of the object, right? It is always smaller, but in the case of convex, it can be bigger and it can be smaller. Okay, these are the two types of lens which we have discussed. Now you have got one more question of the similar nature. Do this one and then we'll proceed to the periscope and kaleidoscope.
$65.
You're saying 65. Okay. First, let us draw the two mirrors inclined at an angle of 90 degree. A ray of light is incident on mirror A. Let's call this as mirror A, this one is B. And it is incident at an angle of how much? It is 25. So this one is also 25 and this one is going to be 65. If this one is 65, this one is 90. So thereby this one is going to be 25 and that one is going to be 65 and this one is also 65. Very good. Option C is correct. Read the given paragraph.
Sir, can you repeat?
Read the given paragraph.
What is a periscope? A periscope is an instrument that is used to look at objects that are not in the line of sight of the observer. In other words, it is used to see objects that are hidden. The periscope works on the phenomena of multiple reflections of light. Inside the periscope, there are two mirrors that are inclined at the angle of 45 degrees. Periscopes are generally used in submarines, tanks, and bunkers by the soldiers.
Okay. Now, as you have an obstacle, right? So will the rays of light reach to your eyes from this object? Obviously, it will not reach since first it is not in direct line of sight. Right now, you cannot look at it even. You cannot even look at it. The rays of light are not going to come from the trees towards our eyes so that we can see it. But with the help of this instrument, where two plane mirrors are inclined at an angle of 45 degree, with the help of multiple reflection, with the principle of multiple reflection, we can still look at the given object. So the rays of light incoming from the object are going to hit the plane mirror. Plane mirror A, suppose we call this as plane mirror A, or let's call this as mirror M1. After reflection from this, it goes on to hit the plane mirror 2 or plane mirror M2. And then these reflected rays of light goes with these reflected rays of light reaches to our eyes and hence we are able to look at it. Now, the construction here is being shown in a very simplified manner. But apart from the plane mirror, we get to see that we take help of lenses in this also. Getting it now? So that is the periscope which you can see mounted on the top of the submarines. It is also used in the bunkers also. So in this one, you will see that use of the lenses is also done. Particularly the use of convex lens is done in this one, apart from the mirror also. Okay. So that is all about this periscope here. Other than periscope, there's a toy called as kaleidoscope, in which three rectangular plane mirrors have been inclined each at 60 degree of angle. On one side of this, you have the end cap on which colorful pieces or colorful circular patterns are placed, right? Or you can paste pieces of tiny bangles or colorful pebbles in it too. So this is the end cap on which all those colorful pieces of beads, bangles, or pebbles are attached. On the other From the other side, you have the eyepiece from which you can look at it. And also this end cap is transparent so that the rays of light can enter from this side. And as the rays of light will be entering via the end cap, so multiple reflections would be taken from these three plane mirrors, and hence you will get to see these beautiful symmetrical patterns. And each time you will look into it, you will get a new symmetrical pattern because every time the reflection will occur differently. Read the given paragraph. Is Prime read the paragraph?
It is a device that works on the phenomena of multiple reflection with the help of multiple mirrors. It is a cylindrical structure with three plane mirrors inside it. It contains several pieces of beads, broken glass, colorful bangles, pebbles, etc. The observer can look into the kaleidoscope from one end, and the light enters from the into the kaleidoscope from.
Okay. And when the light falls upon these objects in the kaleidoscope, multiple reflection of those objects are occurring and thereby creates these beautiful patterns. And since the reflection of light is not always the same, so you will never see a same pattern being repeated in the kaleidoscope. Okay. So that was all about the multiple reflection. What is the formula required to calculate the number of images formed by a form if two or more than two plane mirrors are inclined? If two plane mirrors are inclined at some angle, what are the two formulas? One is n equals to
360 by theta.
okay, and if the value of n came to be an even number, then you subtract.
What, sir?
If the value of n comes out to be an even number, then
Subtract 1.
subtract one. Good. Okay. There is another interesting property associated with light. You see, the rainbow formation and the band of seven color lights, which we get to see when the white light passes through the glass prism, that was due to another phenomenon of light called as dispersion. So, dispersion is basically the splitting of the white light into its component colors. And this, for the very first time, was proved by experiments by Sir Isaac Newton. Okay, na? So Sir Isaac Newton, via some experiments, showed that white light is made up of seven different colors. Getting it now? And back then, when he did this discovery, the painters of that time were astonished. They were surprised by this fact. Okay, so what he basically did, we will get back to that experiment also in a minute. But let us understand this first. So in the case of dispersion, when the rays of light passes from one medium to another, passes through certain kind of mediums or objects like a glass prism or raindrops, so it splits up into its component color, and this phenomena is called as dispersion. Let us understand what happens. What is basically going to happen as the white light is being made to pass through this tiny hole, and as the light is entering into a new medium, so the different colorful components of the light, different colored lights, all of them travels at different speed. All of them are traveling at different speed. And because of the difference in their speed, all of them are bending at different angles, right? So violet also bends indigo, blue, green, yellow, right? Violet light is bending the most. The red light is bending the least, right? So we get to see that all these rays of light are traveling with different speeds, and hence they bend differently, right now. So this splitting of the white light into its component color, respectively VIBGYOR, that is violet, indigo, blue, green, yellow, orange, and red, it is because all the colorful components of light travels differently. Colors at travels at different speed, and hence bends differently. So that is the basis of dispersion of light. Tell me if you're getting this thing.
Yes, sir.
Okay, no, that is one thing. Okay, and like the sky appears to be blue in color, huh? Because the blue light disperses the most, scatters the most. Getting it now? The sky appears to be blue because the blue light scatters the most. Getting it? And the arrangement here is from the shorter to the longer wavelength. Like you know, like for example, in the traffic signals, why is the red light used in the traffic signals? Yeah, why the red light is preferred?
So it's uh, uh, like visible. lot visible.
Yeah, but main reason is that it has longer wavelength. That is why it is used. Okay, now so it will travel longer. It will be it can be viewed from far away also, since it has longer wavelength. While the blue one, violet, indigo blue, they are shorter wavelength. These lights have short wavelength. Getting it now? That is
Yes,
also one important thing to understand. So from shorter to longer wavelength. Okay. And the shorter wavelength light or the blue light scatters the most, and hence the sky is blue in color. Okay. Anyways, talking about the rainbow formation. Like there are certain conditions required for the rainbow formation. First, like there has to be sunlight. Okay. Sunlight has to be there. Thereby, sun has to be low in low sky. It has to be in the lower horizon. Yes.
there's like from the artificial light, like the light bulbs,
Mhm.
like a rainbow forms from them too, or only sunlight.
Now, from that also rainbow formation can occur. Yeah. From the artificial light also rainbow formation can occur. Okay, but the condition is that it should be white light, not the colorful light. Okay. So there are certain conditions required to view the rainbow. So first thing is sunlight. Second, where the sunlight is present, like it should be in the lower sky. Another thing is that the back of the person should be facing the sun. Getting it, like this is where the sun is present, and this is where the observer is present, and this is where the rainbow formation is going to occur. This is where the rainbow formation is going to be occurring. Getting it? No, that is one thing. Nonetheless, what happens here when the white ray of light passes through these tiny droplets of water? By the way, you know that the raindrops are roughly spherical in shape. They are usually shown as teardrop shape now, but they are basically spherical in shape. First, what happens as the white light passes through the passes into the water droplet? So refraction is going to occur now, because we have learned that when the white light or any light passes into a different medium, it starts to bend, and bending of light is called as a refraction, isn't it? And it bends into multiple colors, into different multiple colors. So dispersion is occurring here also. Tell me if you're getting this thing or not. Yeah.
Yes, sir.
Okay. Then from the internal surface of the water droplet, it is going to reflect. And again, when it will be coming to the air, so it is going from the water to the air, there's a change in the medium. So then for the second time, refraction is going to occur, and it will be viewed as a rainbow in the sky. The important condition required for the rainbow is that there should be rainfall and there should be sunlight also. Like even if the rainfall has stopped and there is some amount of raindrops present, and if the sunlight is there, so rainbow will be viewed. So rainbow formation is basically an example of dispersion. Now, as I was saying to you that Isaac Newton basically concluded why experiments that white light is made up of 7 different colors. Okay. See, this is how he basically proved it. See, what Sir Isaac Newton did now, he took 2 glass prisms. Okay, now he took 2 glass prisms. Okay. Now, as the white light were made to pass through the first glass prism, it got split up into different colors. It was again made to enter into the another glass prism that was put in an inverted position. Okay, now by the way, don't get confused with these different colors here. They are not matching here. Okay, now like here, the red light was entering, not the blue, not the violet. You getting it, Ibrahim? What I mean?
Yes, sir.
Good. So it was observed that